This Week in Radio Tech, episode 188, is brought to you by the Telos VX Multi-Studio Talk Show System. Telos VX is the first and only multi-studio talk show system designed for radio and TV broadcast production. Improved audio quality and cost savings from day one. On the web at telos-systems.com/VX.
And now, our feature presentation.
Twert.
IP audio is huge in radio, and now wireless IP video is helping radio and TV stations bring back remote TV shots.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Dad?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land,
this is Kirk Harnack.
Chris Crump with Comrex joins Chris Tarr and me for the latest in digital strategy for radio. It's video.
You're dialed in to This Week in Radio Tech.
Hey, welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack, your host. I'm glad you're with us. This is the show where we talk about radio technology, and man, there is a lot of it out there. I just got back from a big SBE national meeting, and just to see the awards that are given out for engineering excellence, and just the keynote speech by Paul Brenner, who's been a guest on this show. There's just so much going on out there, and technology is just so much to keep up with. And this is the show where we at least try to keep you up on some of that, introduce you to new ideas, and talk about old ideas, and make sure that we all understand some of the basic concepts. So This Week in Radio Tech is the show. It's our 189th episode. I'm Kirk Harnack. I work for the folks at Telos. I'm the VP of the Telos division. And also one of our regular co-hosts is with us, and that's Chris Tarr from, calling in today from Milwaukee, Wisconsin. Hey, Chris, how are you?
Hi there, Kirk. I am the Director of Engineering and Operations for 88.9 Radio Milwaukee, which is where I'm at today in our new conference room. I have to working through our semi-annual membership drive downstairs, so been working hard all day. I'm also a contract engineer all over the state of Wisconsin, contributing writer to Radio Guide magazine, and so much more.
Yeah, you are so much more. Appreciate that. Also, hey, just give a plug for your website. The info website. What is that?
It's the Virtual Engineer, and it's at broadcastengineering.info.
Broadcastengineering.info. You'll find forums there and people who are helpful when you have problems.
Exactly, correct.
Maybe if you're a helpful engineer, maybe you could be helpful yourself and answer somebody's problem at broadcastengineering.info. Our show is brought to you by Axia Audio and the Axia X Switch. I'll be telling you, does that sound exciting? Maybe not, but it'll solve a problem for you, so I'll tell you about it later. Hey, and I want to welcome into our guest, Mr. Chris Crump from Comrex. Chris is the Sales and Marketing Director, and he is a wealth of technical information. Chris, welcome in from what? You're in Atlanta area right now?
I am in lovely Buford, Georgia, with my family and Buford, Georgia, with my little puppy Olive, who is sitting on the sidelines just looking at me.
Well, if you get tired or bored, just put Olive on. We'll carry on.
She could be much more entertaining than I am on many levels.
Chris, I think you may have been with Comrex for about as long as I've known you. Tell us, Comrex is a name like Telos. It's just everywhere in the broadcast business. Tell me a little bit about Comrex and kind of how y'all got started, and it's interesting that Telos and Comrex have made competing products for years, and yet we've always been pretty good friends in broadcast. I know at NAB shows, sometimes somebody will ask a question, we need a product that does this, and our answer will be, well, we don't have that, but the folks at Comrex sure do.
And we do the same thing. I mean, like stereo ISDN codecs, if you need that, go talk to Telos. Those are the guys that do it. And Comrex has been around since 1961. And a lot of people aren't aware of the fact that our very first products were television. We're making audio products for television, things like wireless microphones, VHF monitors, IFB queuing systems that were 26-based. So a lot of that stuff, our first 10 years in the company's existence, when John Chaney, our founder, basically started to put these products out into the market, was revolving around television. And it wasn't until frequency extenders basically popped into our line that we discovered that we could allow radio broadcasters to do much more creative remotes using just a regular analog phone line by shifting around the frequencies down in the 250 hertz range. So it actually made a remote sound a lot more natural over a phone line for those that couldn't basically get an equalized line in. Then we started to develop a line of ISDN codecs in the 80s, followed by POTS codecs in the 90s, and it was the 2000s that got us into the IP world. So now we're making IP audio codecs, telephony interface products like telephone hybrids and talk show systems. And, to make your point, even though we've been making somewhat competing products, it never seems like they directly compete. We kind of fill a niche. You guys fill a niche. So I think we kind of complement each other in a lot of ways.
Yeah. So a couple of years ago, we had on the show a friend of yours and a colleague, Tom Hartnett. And unfortunately, I couldn't be here for that show. I was on a plane to Singapore, I think, at the time. But Tom came on, and Chris Tarr, you were here for that show, weren't you?
I believe I was, yes.
Yeah. Crazy thought. Chris, why don't you tell us everything that Tom told us in that show?
Right. Yeah, we've only done 189 of these, so I really couldn't tell you.
I am sorry I missed that show, but Tom, what does Tom Hartnett do for you guys at Comrex? Lead
Tom, he's our technical director, and basically he helps develop or basically creates the products that I get to sell. So he's the guy that sits in his office and swirls the mist of the future to determine what technologies are out there that we can take advantage to make really cool products for broadcasters.
So I want to run back to something that you mentioned, and that was the frequency line extenders. We're going to dip into history for a second here before we move into the present and where the future's going, because we got some cool future stuff to talk about. What you said stations are doing now, and I think it's going to be very prevalent. But this frequency extender idea, I got introduced to these, I guess, years ago, although I worked in a little small market where we had, of course, dial-up POTS phone lines was how we did baseball games and car dealer remotes and church services on the radio. But in this little town of Berea, Kentucky, the local phone provider was GTE. GTE. And for whatever reason, on a local phone call, they did not high-pass filter the phone call. You had frequency response down to almost DC, which was unusual. Anywhere else in the country, you pick up the phone, you call your across town, and you're 300 hertz about to 3 kilohertz. So that was kind of unusual, wasn't it, for somebody not to high-pass filter?
I would say so, but not to be disparaging against Berea, Kentucky, which I think is off of I-75 as you're headed through that wonderful state. Might have been an engineer, one of the technical guys that said, "What's this thing? I don't know. Let's unplug it. See what it does."
Well, when you only have 4 lines in the state to connect, it's pretty easy to do.
And they were all on a party line too.
Right.
So.
Okay. You were 3 rings, right? Your phone number was 4. Is that right? I, on the other hand, I used Comrex frequency extenders all the time. I worked in smaller markets like you, and I don't know how many Friday night high school football games were carried over a Comrex frequency extender. In fact, we had a setup back in the good old days of the 5-watt bag phone that we had a frequency extender wired into an analog cell phone with a mic jack and everything else, and it kind of replaced a Marty. And it really did. Those frequency extenders were fantastic devices. I mean, you really couldn't go to too many radio stations that didn't have one of those frequency extenders sitting in their studio. It just opened up a whole new world for remotes, because again, a lot of times you're either tied to Marty systems, which weren't always, you couldn't always get a good signal, or it was picking up the telephone and getting that telephone quality sound. And the frequency extenders were a fantastic product for their time, because all of a sudden now, if you could find a phone that you could plug this thing into, you were good to go.
And it's funny because occasionally we get calls from people that have a bag phone and they've got a frequency extender, and they say, "Hey, can I get this thing to work?" And it's like, no, they turned off the amp service that your bag phone uses about 10 years ago. So that's going to be a real trick.
Right. Well, one thing that we ought to cover real quick. I'll give the 5-sentence explanation of this if I can. Then Chris, you correct me if I'm wrong here. Back when a lot of remotes were done over local phone lines, and a local dial-up telephone line is typically frequency limited between about 300 hertz So, the bottom end of male voices do not get carried through. It's 300 hertz up to about 3 kilohertz. And there's signaling that used to go on above 3 kilohertz. And I forget why. Oh, well, a lot of times the carbon button microphone in the phone itself would self-limit you to 300 hertz. But if you did that, you always got that nasally telephony sound. And if you could have gotten through some of the more bass frequencies, it does make things sound more natural. It makes the brain work less hard when it hears audio. Your brain's trying to fill in what it's used to hearing. And so Comrex came up with this way to take audio out of a microphone, out of a mixer, and take that audio and shift it up in frequency by, about 250 hertz, shift it up. So if you'd listen to this raw audio coming out of this thing, you'd hear it, you'd hear it shifted up in frequency, and then you'd shove it through the phone line at this shifted up frequency, and then at the other end, when you receive it from the phone line, you'd shift it back down by 250 hertz. And this had the effect of allowing the bass frequencies to get shifted up, pass through the phone line, and then get shifted back down to the original bass frequency. And since our ears, we hear audio frequencies based on octaves and not based on decades. If we can add audio between 300 hertz all the way down to 50 hertz, we've added a couple of octaves of audio, and we've just lost a portion of an octave. We've lost 250 hertz, up near 3 kilohertz of audio as the trade-off, and that's a great trade-off for comfort and intelligibility of the audio. It doesn't give you more high frequencies. In fact, you lose a little bit of high frequencies, but you gain 2 octaves of low frequencies, and it just made it sound better. Now, Chris Crump, did I say that about right, or am I off base?
I'd like you to repeat that whole thing again because I was taking notes. No, I mean that's pretty good. I really couldn't add to that. I mean, Tom Hartnett could certainly contribute to that conversation, but that's essentially what these things did. And they, nowadays, I mean, some people still use them, but it still kind of sounds like you're talking into a box in a way. But at the time, it was pretty amazing, even though it only took you up to the 3 kilohertz. But the bottom actually made the audio sound so much more natural. On the other end, talking about technology today, on the extreme, you've got what CDMA telephones are doing to the quality of the human voice. And in a presentation I did yesterday at the SBE meetings and the Indiana Broadcasters Association, kind of talking about how CDMA phones basically rip all the humanity out of the voice because it's digitized, it goes through a vocoder, and any semblance of a human voice is kind of all ripped out, so your brain has to work harder to fill in all the holes. So with smartphones, you would think that audio would be getting better, but it's actually getting worse. But there are ways that you can make it better, and that's some of the technology that we're working on these days.
Yeah, and we're going to get into that with you guys putting Skype into your on-air phone system so people can talk that way, like we're doing now, except without the video. And and maybe there's some more ideas too. But you're right about this other impairment. When we went to digital cell phones, and the cell phone providers went to either proprietary or other very low bit rate codecs. We've all, struggled sometimes to understand somebody on the phone. And sometimes we're operating down at 4, 5, 6 kilobits per second for a codec to get audio from the phone to the phone company. Now, it may get turned back into G711 somewhere else, or maybe G729, but whatever codec that some people have used, or modes that they may operate in when they need low bit rates, oh my gosh, they can be terrible. And it's this kind of impairment that you can't really just go measure with frequency response or maybe distortion, because it's not tonal based. It's there's psychoacoustic encoding and a lot of math going on.
They do what's called pseudo noise encoding. So the vocoder is a part of that, and what they're trying to do is they're trying to take 8 voice calls and cram it down a single voice channel so they can get more calls on their network.
Somebody in the chat room mentioned a 2-line frequency extender. Was this something that Comrex did as well?
Oh yeah, that was big time. A lot of people use those. We actually came out with a 3-line extender as well, which was a little challenging. I think people were happy with the 2-line. The 3-line got a little bit difficult to get all the lines kind of in sync.
So with two lines, what you were shifting one audio up 250 hertz, another audio you were probably shifting up about 2,500 hertz or so.
So you brought back a little bit more of the higher frequency response.
Yeah. So in the end, you'd get about 5 kilohertz of audio response out of two ordinary dial-up phone lines. Yeah.
That was exactly it. I mean, it was a magic 5 kilohertz box with two phone lines, and we sold a lot of those, and we still get those in for repair occasionally.
Wow.
It's funny because I have to tell you, Ed Schwartz from SiriusXM, right after that little announcement from Verizon came about them discontinuing a typical PRI or BRI service on the East Coast.
Right.
Ed Schwartz sent me a note saying, "Hey, do you have any of those two-line frequency extenders left?"
Yeah.
I was like, maybe we can go back into production on those. That would be awesome.
Is there a reason why those wouldn't work over VoIP circuits? I mean, not connected directly, but if you had an ATA, if you were a POTS connected to an adapter, and then your infrastructure was VoIP, any reason why that wouldn't work?
You know something? I really have no idea, and this is just full disclosure. Those are actually before my time, and I never actually really used one. I just see them come in from time to time. But honestly, I wouldn't know.
Let me tell you, you young whippersnappers.
You guys have to tell me this stuff.
It actually should. I mean, there's no reason why it wouldn't work. It's as long as it comes out the other end with that audio pitch shifted, it should work. There's really nothing secret about them.
Yeah. Well, certain things don't like fax machines don't work well over regular VoIP lines, but there is a standard that it can invoke to get that.
There's a difference too, because with a fax machine you're trying to throw bits out, and this is actual analog audio that's shifted. So there should be no reason why it wouldn't work. On the other hand, if you're doing an ATA to ATA call over VoIP, you already have much better bandwidth than you did over a POTS line anyway. So it probably have about the same quality as if you used an extender.
Depending on what codec that the provider, the VoIP provider, is using. Hopefully they're using G711, but a lot of them use G729 or other codecs of them. Now that bandwidth just keeps getting cheaper and cheaper and cheaper. If you've got a VoIP provider that is giving you some crappy codec because it's lower bit rate, you need to talk to them or change providers. There's really not an excuse to at least use G711.
My provider, we have G711. You can definitely tell when somebody else calls in with that because it sounds phenomenal when we get that calls.
So there's at least providers that are out there, so plenty to choose from.
Yeah.
So Chris, the next thing I want to ask you about is for some years we had this technology of dial-up modem type calls that we ran digital audio through that, right? Mm-hmm. So tell me a bit. Service. Yeah, but we had a box we'd take out, hook it to a POTS phone line, establish a call to a similar box back at the studio, which was also on a POTS line, and then run some fairly low bit rate audio. I mean, there'd be a codec there to run your typically mono audio through all that. Tell me about that era. Is that about the time you joined up with Comrex?
Yeah, just about. I mean, the POTS codec technology kind of came about as a result of computer modem technology, being able to digitize audio, send it across as packets across a circuit switch data network. And it kind of required that you had the ability to pass serialized data across that network, which is why you can't do it on IP or voice over IP. But it was a relatively simple technology. Basically, you just dial up a phone number on the POTS codec, which is the receiving end. They establish a connection, and they're capable of doing up to 15 kilohertz dual mono back and forth over a standard phone line.
So what codecs were Comrex made a number of products like this, and I believe Tyline did too. Telos really only made one product that worked in any kind of way like this. So I think you had the Blue Box and the Vector. What other products did Comrex make?
The very first product was the Hotline, and that's really the product that that got us kind of on the map, and everybody had. I mean, there are people that still use those on a regular basis, and so it was a huge product for us. That was early on, and then as computer modem technology developed, we're able to put in new devices that actually improved the fidelity of the call. and different components that actually improved it quite a bit as well. So after that came the Vector, which was kind of a cool box, and then we did the Matrix, which was a POTS ISDN codec, and then we did the Blue Box after that. So we had a very good line of successful POTS codecs that really kind of carried us for a couple of decades. Now,
it seems that POTS codecs, just like computer modems, like you'd have in your laptop or your desktop machine, the technology of a computer modem with the squeaks and the squawks and getting every bit of bits through a connection by frequency and shift, frequency shift keying and all this through a given connection. That's what all the squeaks and squawks are, setting up the characteristics of the phone line. It seems that this always worked best on what I call real by golly phone lines. Not a university's PBX with a 12-volt battery or something like that. What was your experience and what was your customer's experience in finding out where does I know we're talking about 10 years ago or more, where did a Comrex Matrix work really well, and where would this kind of technology get challenged in terms of the type of phone line you were connecting to?
Well, there were so many issues that a customer was confronted with because not all phone lines are the same. You could have a pair of copper that your phone line is delivered to you on, and the wires could be cracked. They could be lying in a trough full of water and shorting them out and creating just enough noise on that line so that the lines wouldn't equalize and pass the data through sufficiently. Actually, an equalized line was a great line to be able to use for that, or definitely not a PBX, because that actually caused some expense in terms of a bandwidth that was available for you to transmit. But there's so many. Another big issue we had was calling across a lattice between states or providers. That could always cause problems. So many issues that I'm glad that I'm into the IP world, because it kind of brings back a lot of headaches and bad memories of.
It's interesting because as engineers back in the days, I started, I bought one of the first hotlines that came off the assembly line. You learned as an engineer, you had this checklist of things that you worked on when you're going to do a remote, because you knew those things. You also kind of had a bag of tricks. Like I had an adapter that allowed the hotline to connect through a PBX system through the headset, so that you weren't having, if you had a true PBX line, it's not analog, so you couldn't actually dial out on it, or if you plugged it in, the voltage would smoke the modem or whatever. So you had those adapters that you could insert in between to get audio. But you'd always check. You had the checklist of you're going to do a remote. You check the internal wiring. You check the DMARC. You'd kind of see how things would work, and then usually a pre-remote checklist would involve dialing it up and leaving it connected, or at least knowing how to set the maximum rate, crank it down so that it wouldn't constantly renegotiate. But you tended to learn pretty quickly the ways to efficiently set up those codecs so that they were pretty reliable. And again, I mean, that was one of those situations where that opened up a lot of possibilities for a lot of stations. And I still the sports station here with Intercom that I still do some work with, they still use a matrix, and they still use they use it for POTS and also for switch data over cellular. For that codec, and it works spectacular because, again, IP is great, and we love IP, and IP, if you can get good IP, works. On the other hand, still to this day, nothing beats a good solid POTS connection.
Nothing?
That's true.
Nothing.
What for a POTS codec?
Correct. I mean, you're either ISDN or POTS. You're not going to have. You generally don't have the same potential issues as you do that you do with IP. Because again, you go to these remotes, what do you get? You've got the remote, the business's house system, which is usually Wi-Fi or a cable modem or DSL, and then you've got to get it back over the public internet. Now, again, the IP codecs has gotten much better with that, but I call it the law of averages. When you're doing a sports talk show and you're talking live for 45 minutes out of the hour, the odds of having an IP issue or an IP dropout are much greater than, for example, if you're a music station and you're just doing some quick talk breaks through an hour. So,
sure.
So, oftentimes with a situation like that, if I can't be certain that the quality of the IP connection is going to be really good, I'll usually default to a POTS codec, and especially on AM, it really doesn't sound bad at all.
So, Chris, you sound like you've had some better luck with POTS code. It seems like in the late '90s, early 2000s, a lot of POTS connections weren't really POTS. I mean, they switched to VoIP somewhere nearby, or they went through some kind of muxing thing. The phone company was out of facilities, and so they put little boxes around that let them get 3 phone circuits into, or 4 into one pair. They started using a lot of digital technologies, which if you were a voice talker, you couldn't tell the difference. But a modem wouldn't work well over that. Have you not experienced that kind of problem?
No, it seems like. Oh, I'm sorry. I'll answer that quick for at least in my neighborhood. At least in the Midwest, especially in our area, we really the AT&T hasn't moved a whole lot to fiber yet. So, for example, ISDN lines are easy to get and plentiful. POTS connections are generally true POTS connections. There isn't a lot of fiber conversions. I understand that out east, especially, that's a whole different situation. And Chris, you probably get this all the time from your travels all over the country.
Mm-hmm. And I've had a lot of calls from customers probably about 10 years ago when they were making a lot of conversions within central offices, because the phone companies have told us that they want to get rid of circuit switch data services, so they don't want to have to support these huge mechanical rooms of switches within the central office. They just want to put Cisco routers and switches and hubs in there and get rid of the 5 ESS switches and all the circuit switched data equipment. And I would take calls from customers that were just livid because their matrix stopped working all of a sudden, and they wanted to know what I did to it. And I'm like, I didn't do anything to it. Has your phone company made any changes within their central office? Yeah. Well, what did they do? Well, they did some VoIP thing. I went, oh, well. So they would basically connect, and it would stutter, drop. And that's because, again, the POTS codec relies on that serialized data stream to basically be able to get from end to end. And if any of those packetized pieces of serialized data are interrupted, don't have a connection.
Maybe somebody in the chat room knows differently, but it was always my impression that the phone company has been G.711 inside the phone company for a long, long time. And so if you go from an analog phone line into a proper G711 converter, and now it's carried as very simple G711 in the US would be ULAW coding, and then you come out the other end from G711, wherever it gets switched, and then to a POTS line, then back into a POTS codec. That works. That's not a problem. G711 is very accurate and not problematic for modem type signals. It's when they went to other codecs, especially psychoacoustic codecs, because G711 is not psychoacoustic. It's just math. It's just fast math, low delay, and low frequency bandwidth, but it matched what phone analog circuits were designed for. But when they started going to other codecs to get lower than 64 kilobits for the bit rate, they started, remember 15 years ago when everybody had to have a fax line as well as their usual lines? Man, I mean, the phone companies in some places had to, increase their capacity by 30, 40, 50%. Because of all the fax lines that were being bought back then. Anyway, my point is that there were technologies that to my understanding, screwed up your modem type connections. Remember the days you took a laptop to a hotel and it just wouldn't connect very well? That's the kind of thing I'm talking about. Either crappy PBX or psychoacoustic encoding, which is fine for voice, but not fine for when you've got to transmit, frequency shift keyed at lots of carriers. It doesn't work so well for that. I'll get off of this subject. Anything else to add about what I said?
Well, I think I think the phone company's actually been pretty good about the copper to VoIP transition, because there still are a lot of fax machines out there and they all work. So obviously there's a pretty good chance that if you're hooking up to a POTS line, a voice codec like that will work. So that's number one. And number two, I know as an engineer, I always have to be specific nowadays with businesses when we're going to use one of these devices. And I have to say specifically, do you have a fax line? Because a lot of times they go, oh yeah, we've got a phone line, and you go in and it's a VoIP line. And you go, well, that's not going to work. I need a fax line. But I like I said, knock on Formica here. I really haven't had any issues. Every time I've ordered a POTS line, unless it's wired improperly or something like that, I've always been able to get a hotline or a matrix or what have you. I've always been able to get it to work on POTS, and in fact, a lot of times it works better than anything else.
You live there in the Midwest where people are nice and the engineering's good,
and the POTS flow free.
The POTS flow free.
And I have to tell you, one of my favorite Comrex tech notes when I first joined the company basically told you how to make friends with your local telco guy. So that's just another little trick in your tool bag where you basically give them a pair of concert tickets, T-shirt, some station mugs. And it's amazing how many people have had to rely on that kind of bribery to get their remotes on the air.
Oh, yeah. I agree completely.
And we thought that was just in third world countries. But no, bribery works here, too.
Even in Milwaukee, right, Chris?
That's right. Well, bribery is the international language.
That's right. Mm-hmm. Hey, you're watching This Week in Radio Tech, or listening to it. I'm Kirk Harnack, your host, along with Chris Tarr from Milwaukee, Wisconsin, and Chris Crump, the Director of Sales and Marketing for Comrex, makers of fine codecs and IP and POTS codecs and phone systems, and something really cool we're going to talk about in just a few minutes. Our show is being brought to you by my employer and my friends at Axia Audio, and makers of something kind of new. It's the actually it's just been shipping now for 3 or 4 months. It's the Axia X Switch. Now, Axia brought out live audio over IP, very low latency, very high quality. Brought that out, it's been now almost 14 years ago. Steve Church gave a talk about this in 2002. I think we started shipping some products in 2003 and 4. And so it's been out there for a while. One of the things that some engineers have had some trouble with is getting switches. Typically, these are high-quality switches from Cisco or HP, and getting them configured right. Inside a Cisco switch, there are a ton of command line configurations that can be done, and some of them do need to be done to work with extremely low latency live wire IP audio packets. Well, Axia decided, hey, let's make our own switch. Let's make our own switch that's pre-configured, that's guaranteed to work. Now, it works with all other kinds of traffic, too. It's fully compliant with any kind of traffic that you want to throw at it over an IP network. But it's also it comes ready to work with live wire IP audio. Also, in fact, it uses the same chipsets that are found in the really expensive iron, chipsets from Marvell, for example. Another thing that the X Switch does is it gives you some ports that are PoE, power over Ethernet, and that's pretty cool too. So the X Switch is very easy to set up. There's virtually no configuration. I think there's a couple options if you really dial into it. You can, it's powered by AC, of course. It's just a half rack wide, and let's see, I should have been better prepared. Let's take a closer look at the back side of one of these. It's got 2 of those SFP port, the small form factor pluggable. So will it connect to fiber? Absolutely. Just buy a fiber adapter for it. And this is a real standard off-the-shelf thing. And it's got 2 ports for that. It has, I believe, 2 gigabit ports on it. And it's got 8 100 megabit ports on it. The 100 megabit ports are what you usually connect to all kinds of peripheral devices around your studio. Any kind of live wire stuff from Telos or Omnia or Axia, or from other companies that have a live wire port on their gear. And 4 of those ports provide you with power over Ethernet, PoE. So if you've got VoIP phones like these that are behind me for your phone system, you can plug them right into that. The power will come right from the switch. It'll power the phone, plus give you the full Ethernet capability right there. So the X Switch, easily deployable in studios. If you just need, I got to put a switch here. You don't want to buy a Cisco switch that's maybe kind of big or takes a lot of time to configure. You just don't want to mess with that. Get an X Switch from the folks at Axia. By the way, it's the same physical form factor as also the Axia X Node. So if you need a couple things in a rack, like an X Node to provide you with analog or AES audio in and out of your live wire network, pair it up with an X Node right next to it. And that X Node will, of course, run the X Switch and can run other things as well. The X Switch will run the X Node and other things as well. Something else to consider, the Axia's X Nodes, this is the audio interface that's available for, old-fashioned stuff that uses analog or AES. These can be powered with AC power or with PoE, power over an Ethernet. The power budget for an X Node is about 15 watts. And so you can power it with PoE, power over Ethernet. Well, you can get that PoE from the X node in the same rack or in the same 1RU or elsewhere in the room. The point is you can dual power your X node with AC power and PoE from, say, one of our X switches. So if you want to check it out on the web, go to axiaaudio.com/X switch. Make that like one word, the letter X and then the word switch, and you can read all about the X switch there. It's really cool. They've done our guys in R&D have just done a fantastic job of designing this thing and setting it up and making it easy, super easy to use. All right. Thanks a lot for Axia Audio being our sponsor on This Week in Radio Tech. Oh, by the way, it's got this really cool OLED display on the front, and you can see at a glance the status of all of the ports, including the gig ports and the SFP ports, and whether they're providing power or not to devices they're hooked to. Check it out, axiaaudio.com/xswitch. All right, you're watching episode number 189 of This Week in Radio Tech. I'm Kirk Harnack, along with Chris Tarr and our guest, Chris Crump from Comrex. And Chris, we've been talking about the past here. Yeah, I guess it's time to shove right into the present and the future. You were telling me,
thank you
Chris,
very much for doing the future, because I have left so much of that behind me, and my brain is so full of everything that I'm doing now.
We're causing you flashbacks.
It's like, oh my God, I don't remember any of this.
Yeah. So, Chris, earlier this afternoon we were talking about your recent experiences walking into radio station studios and being a little surprised at the non-radio things that you see. Tell us about what trend you're noticing.
Well, I travel all over the world, and I'm into radio and television stations all the time. And it's been really surprising the number of radio stations that have either a full video editing suite or studios that are just filled with cameras and lights because they're basically contributing to a television morning show, or they're broadcasting their shows on cable. I'm seeing it with a lot of sports talk stations in major markets. I mean, look at what Kid Craddock does with his Dish Nation and all of the stuff that they're doing video-wise. So radio has really started to make a leap away from just being an audio source. They're becoming content creators, and they're basically contributing content for cable channels, cable networks, and even just local television shows, and the web, of course. That's a big part of it as well.
All right. So, and I've tuned around to some European radio stations on the web and seen them producing video. And Chris Tobin, who's one of our regular co-hosts on this show, not here this week, but usually is, often mentioned that the CBS radio stations in New York actually produced a lot more video every day than the CBS television stations. Of course, it typically wasn't broadcast over the air. It was streamed on their websites, but if you wanted to watch a talk show being made, there it was. Chris, I take it you're seeing a lot more of this outside the U.S., or what are you seeing in the U.S. as far as video?
Well, in the U.S., if you talk about CBS, it seems like all of the groups in major markets that are consolidated, they all have a digital media director in that market who's responsible for the video content for the websites or for streaming or however they want to present. But it's really a big part of what I know CBS is doing. I was in Clear Channel San Francisco a couple of weeks ago, and I was really amazed because they have a full-blown editing suite. I mean, that rivals a lot of TV stations that I see. So it's really, stations are investing in video because, what is TV other than radio with pictures, right? Don't tell
Chris
that to
Tarr.
a TV guy.
Chris Tarr, either at your facilities you used to take care of, Intercom, or where you are now at Milwaukee's 88.9, what are you seeing in terms of video or prep?
Same thing. We have Intercom. I'm still involved with them, and they have a director that essentially does nothing but video all day. And they go out and they shoot, and when we built the facility here, we had video in mind when we planned it, and we have a professional guy who does a lot of our video. So I think everybody's doing it now, and it's just a matter of starting small and ramping that up. And I think the price points have come down, and the quality of the tools have gone up enough to where in the hands of a skilled producer, it's not all that difficult for radio stations to produce video content. So I think what Chris is seeing is pretty common across the country. I think we're seeing more and more of that because, again, I mean, we have the on-air component, which is great. I mean, it's our audio, it's what's on the radio, it's what's on the website, but we have to come up with ways to bring people back to our websites to do things. And websites typically have been static, not changing very much kind of entities, where you go and visit it once and you don't go back. Same thing with Facebook and other types of social media. I mean, it's great that we're posting status updates about what the jocks are doing and things like that, but that's not real compelling. On the other hand, when you can create video content that includes their favorite radio presenters and some of the things that go on behind the scenes and even some of the in-studio concerts and things, that's compelling video. That brings people back to their websites and engages them in social media. So it's almost something you have to do at some point or you're going to miss the boat.
Interesting. Now, at my small little stations, I was thinking we don't do video, but yeah, we do. In American Samoa, we actually have a very manual. So we have some lipstick style cameras around the studio, and we hire a guy to come in and push buttons and switch cameras. And then when songs are playing, I think we're running video billboards, happy birthday, fololo, and that kind of thing in American Samoa. So I feel like I'm a bit out of touch with some of the bigger markets and what they may be doing in terms of video. But one thing I have noticed, I don't know if I don't want to spill all the beans here. We're going to get another tour later on. But Gary Klein was with us 10 episodes or so back, and he gave us a tour of the new Nash facility in Nashville, the new Blair Garner studio there, and it's fully outfitted with HD cameras. They're not streaming anything yet, but they will be sometime early next year, along with social media stuff and weather forecasts and just all kinds of fancy schmancy stuff. So it's really going to be video. But I didn't mean to run off on that tangent. We're here to talk about Chris, and Chris, what you and Comrex are doing, what you have to offer to video content and producing that content. Tell us where Comrex comes into that.
Well, obviously we have a lot of experience with pushing IP over data networks, whether it's the public internet, 3G wireless, 4G wireless, and just regular IP type networks. And at NAB several years ago, we just got bombarded with people that came up and they looked at the Access audio codec, our flagship product, and they said, we love the form factor of this. It would be great if it did video. And well, we don't do video. We're an audio company. And then we kind of had conversations about it internally, and we figured that we could probably do a video codec and kind of go back to our early roots of television. And so we spent a lot of time and resource and engineering effort to develop the Comrex Liveshot, which is our video over IP codec, which essentially does for video what our Access does for audio. And I just happen to have one right here. Look at this.
What? That's tiny.
It is. It's very tiny. So it's not a lot bigger than our Access audio codec, and it's designed to fit onto the back of a standard Anton Bauer mount professional video camera. The Anton Bauer battery just chunks on to the outside of it like that, and then you take the output of the camera, whether it's let's see if I can get this on. Okay, there we go. HD SDI, SDI, composite, or HDMI. There's an SDI loop for feeding a monitor or some kind of recording device. But the interesting thing about this is it's a full duplex audio and video codec. So not only can I send high quality and audio and video back to the studio over IP, but I can also take a return as well. So I could have, Kirk, you could be doing a weather forecast out in the field, and you could get green screen back, as long as your green screen doesn't blow away in the tornado behind you.
Yeah. So it's fully two-way then. So what one has to ask, what kind? Yes, some of these, there are other live multi-modem solutions out there, but I hear some of them have just incredible delay. I think you guys have a much shorter delay than some of your competitors do.
Optimally, we shoot for like 200 milliseconds of encode delay, and that's pretty average, regardless of the bandwidth that you're using. And the propagation delay might be an additional second or two at the most. So our whole goal is, with your full duplex interaction of your broadcast, you're able to actually talk with the, I just hit myself. You're able to talk with your host, your anchor back in the studio from the field and have a comfortable conversation back and forth. And that's kind of the whole purpose of this product: low latency, high quality audio and video with an audio Q channel as well. So you could have just a completely discrete IFB or audio Q channel offline, so your cameraman can get directions from the director back in the studio, in addition to having program audio and video return.
Yeah. Now, the form factor you're showing there, of course, that's a form factor that a lot of radio engineers, including myself, were not very familiar with until you explained it to me. And you said that's the standard mount on the back of a camera for, I think you said an Anton Bauer battery. There's a couple of different mount styles, aren't there?
Yeah, the other one that's pretty popular is the Sony B mount, which you would find on a Sony camera. And that's pretty popular in Europe, but in the United States, this seems to be the dominant mount. On the West Coast, you have a lot of folks that use the Sony B mount, but we have adapter plates for that. So the two basic industry standard mounts in the television industry or the video industry are the Anton Bauer mount and the Sony B mount.
Now, what are those two gooseneck microphones there on the top?
Well, if you want to talk, you just talk into it like this.
Yeah. What are we looking at?
No, this is a little Comrex innovation. It's and you ask what Tom Hartnett does. This is what Tom Hartnett does. He comes up with these cool innovations. This is actually a USB mast, and so what this does is it keeps the devices kind of separated from each other, so there's no RF interference, and also gets it away from the cameraman's head, so he doesn't get a tumor in his brain. So we kind of like to get these up and out of the way of the cameraman, so you get a little bit better reception on these devices. But
and
so
as engineers, we believe that would be helpful. Do you find empirically that getting the antennas up and out of the way and apart from each other is indeed helpful to the signal levels?
We do find that it really helps.
Mm-hmm.
And in some cases, we might have to add, because these things radiate maybe a watt or sometimes a little bit more. So we can put an RF choke on this to actually improve the signal as well. So there's a lot of little tweaks that we have been making on this device over time. But this is it's been a really nice device, and right now we've got several stations around the country in the U.S. that are using it, but it's really popular in Italy right now. They're loving it over there. They're actually using on Ka-band satellite, and they're doing live broadcasts from all over the country of Italy over satellite.
Can those you showed it with some modems there? Can they also hold a Wi-Fi USB stick?
Yeah, this is our dual band Wi-Fi that comes with it, and the great thing is, I could have a Verizon and an AT&T. I could have a Sprint. I could have Wi-Fi 3G, Wi-Fi 4G. Basically, the technology we've developed, it's called crosslock technology, creates a secure VPN tunnel between this portable unit in the field and a rack mount unit in the studio. And it basically muxes all these channels. It bonds these devices together so you can take advantage of the cumulative upload speeds and download speeds of both of these devices. And it does a very intelligent analysis, sophisticated analysis of what's happening on the network. So if it senses that the bandwidth is being throttled, it can load balance to the other device. And it can actually do some variable bitrate encoding on this as well, so that it can reduce the amount of bitrate required if the bandwidth on the network reduces. And it does that dynamically. You might lose a little bit of fidelity in the image quality, but it will ramp back up as it improves.
So I was going to actually, I think you've answered that, but I want to make sure I understand. At first, you said you can aggregate the speed of these two devices. Maybe it's two different 4G on two different carriers. Maybe one's Wi-Fi going to a good hotspot, and the other one's going to a carrier, whatever it may be. But you've got two streams available here, and you can aggregate those and get a higher overall throughput and then a bigger bit rate for your video and audio. But I take it that if one of them is getting impaired pretty badly, you're going to want to throttle the bit rate down. How do you decide whether to use it for more bit rate or for just redundancy that you may be needing because you're in a bad spot? Is there like an automatic algorithm that decides that?
There is, and the engineers won't tell me how they do it. They just say, "Oh, it's secret sauce. It's too complicated for you to understand." It's magic.
So the box at the studio, what does that look like?
I don't have one here right now, but you can see it on our website. It's just a 19-inch rack mount device. It has a little navigation button and an LCD panel on the front, and then it has analog AES audio in and out. It also has that audio Q channel in and out. Then it has a couple of BNC connectors for HDSDI in and out, composite in and out. And then there's an HDMI output for monitoring. Relatively simple box, but it's essentially this box in a different form factor and slightly different connectors.
So you call this a live shot, and obviously you put this on the back of a professional camera and you do a live shot back to the studio. Is there any reason why you couldn't, let's say you wanted to do a remote production with 2 or 3 cameras, could you switch them and just use that live shot as a kind of a fixed base and shoot that back to the studio?
Yeah, that's kind of what the cross-lock technology, well, first of all, you could actually have multiples of these associated with a rack device back in the studio, and you could switch between them. But yes, you could actually have a rack mount in a truck and a rack mount back in the studio and just transmit over IP, take your output off your switcher into that device and feed your audio over IP, or audio and video over IP back to the studio.
Wow. So what do radio engineers think when they begin to get presented with this notion of, hey, you're going to have to do video now too? What process? I haven't had to do that much yet, and I know a little bit about video anyway. But what do you find in the field? How do engineers take to this?
Well, I find that they can be hypercritical of video quality, so their tolerance is a lot less than professional video engineers.
Really?
Yeah. Because I think they take it very seriously and they want to make sure that it's done really, really well. Because they are radio engineers, or that's been the case in some of the folks I've talked to. But some people really embrace it, and a lot of times, I mean, if you look at a group like Journal, for example, where they've got co-located radio and television, it's kind of, there's a natural synergy there, and they can kind of lean on television to make that work. And another, like Capital Broadcasting would be another example. I mean, there's some synergy between radio and TV, so they can kind of lean on their video engineers. But all of us who are radio people, first and foremost, we're going through a really intense education, learning about video, and it's not an overwhelming challenge, but it's certainly a lot of stuff you've got to learn to basically make all this stuff work.
Chris Tarr, you still with us?
Huh? Oh, no. No, he's yeah, Chris is absolutely right. There's a learning curve for us, and I do think that a lot of times we're more critical about the video than TV engineers, just as probably TV engineers are more critical of audio than we are. It's one of those things where we think that we need to be, because this is something that we're not as tuned to as TV engineers are. However, I do see things like these coming into play in radio for, wouldn't it be great if, I know, for example, the Top 40 station here, Intercom station, does a Christmas bash every year, which is a big event. Wouldn't it be great if you could do that live on the web, professionally? I know with us, sometimes we, with 88.9, we do concerts outside of the building. Wouldn't that be great, just to be able to do those from a remote location? Right now, I find a lot of times, radio stations with their video, it's all locally produced, or it's acquired and recorded offsite and then put online afterwards after it's been produced. We're just now getting into having those capabilities of, doing a live broadcast and also having live video accompany that. I think that's going to be in the future for sure. And I think that if you're a radio engineer and you're not looking at these things and you're not thinking about those things, you're going to be in trouble, because it's going to get to the point where you're going to be forced to, and you should probably start brushing up on it now while you can. I am excited. I saw little glimpses of that Comrex product in some of the trade magazines. It's really interesting to see that in person. And it also, leads me again to, my half joke when I walk around and say, "Oh, internet, is there nothing you can't do?" Because it really has. I mean, if you think about 10 years ago, some of the things that we're talking about right now, I mean, imagine trying to do those 10 years ago. I mean, the cost involved in doing those things. And all of a sudden, the internet has come around to be this great equalizer. And we have these innovative companies like Telos and Comrex and Tyline, all looking at IP technology and creating these, they're not cheap, but they're lower cost ways to do all of these things that we could never imagine before. It's just it kind of, reminds me it's a great time to be doing this. It's a lot of fun.
The one thing that I will say, I mean, in terms of video for television, this is focused primarily at doing a remote broadcasting, getting audio and video from a remote site back to a studio, or even from a remote location wirelessly back to a truck, and then microwave or satellite back to the studio. I've been really amazed as I've traveled around the country at how many radio stations own technology like a New Tech TriCaster, which is basically a little TV channel on a box that basically is a production, editing, and streaming all in one, or a Rushworks system, or there are scads of others. So I think people are making an investment in this technology so that they can actually provide that content and, like Chris said earlier, not be left behind.
So, Chris, I'm curious, and people in the chat room are asking a bit. With your audio codecs, there's been some. You guys have done some development of your own codec, and you've used some industry standard codecs. What kind of video codec is being used for this transmission from the? We're using
H2. We're using H.264. That's a pretty standard, ubiquitous encoding. It's basically MPEG-4 for video, but H.264 is the standard. We basically are doing something a little bit different. A lot of people just use like the main profile of H.264. There are actually I have a chart around here somewhere, but there's like 7 different profiles within the H.264 encoding algorithm, and you can actually leverage those to get better image quality, lower latency, lower bit rate or higher bit rate, depending on what you want. So there's a whole slew of those that you can choose from. And we typically will use all of those based on what profile you've selected.
Gotcha. Chris Crump has been our guest on This Week in Radio Tech, but we've spent half the show talking about video and how to get video from a remote site back to your radio or TV station. And that's pretty interesting. And I think we're going to see a lot more video, as Chris Crump has seen himself at various stations. And Chris Tarr's been involved with this too. Going to see more and more video at radio stations, something we're going to have to learn about. First, it was IT. I mean, like in the period of this show's operation, IT has come along, IP has come along big time, and now video. We're going to need to be adding that too. So, Chris Crump, thank you for being with us. Anything you'd like to add about where to contact you and how to find out more about the live shot or other Comrex stuff?
I will say one thing, and one thing I've noticed with radio stations doing video, a lot of times they don't get the lighting right, and that's really a huge part of making sure you have good video. So there's so many things you have to consider when you're looking at doing video. But if you want to look at what we've got for doing remote broadcast for video, you can go to comrex.com, COMREX.com, and feel free to give us a call in Devens, Massachusetts, 800-237-1776. All
right. Chris Crump, thanks for being with us. And Chris Tarr, I understand you've got to go, buddy, but thank you for being along with us and taking the time to get on the special time of This Week in Radio Tech.
Glad to be here. I got to get back to trying to raise some money for Radio Milwaukee. And, one thing you just mentioned that, I wanted to reinforce is that, video is now radio tech. I mean, it really is. It kind of encompasses all of those things now. So it's interesting how we've progressed. Being a broadcast engineer in radio means not only the transmitter, but IP and video and all these other things. So, pat ourselves on the back for being so gosh darn talented.
We're going to have to do some how-to shows about video, about what HDSDI means and what is HDMI, and do we still use composite here and there, and what to buy when when your GM says we're going to do some video of the morning show on the website. What do you got to do? You stick a webcam up and get on Ustream, or something more sophisticated? It's going to be interesting. All right, Chris Tarr, thanks for being with us. Chris Crump, thank you for being with us also from Beaufort, Georgia. Appreciate you.
Thank you, Kirk.
All right, our show's been brought to you by Axia Audio and the Axia X switch, the newest member of the Axia family. It's a little Ethernet switch that has really a lot of power in it and handles live wire streams just perfectly, plus anything else you want to throw at it in the IP world. Check it out on the web at axiaaudio.com/X-Switch. Thanks to Andrew Zarian for producing today's show. And you can always check us out on our website at thisweekinradiotech.com. You can watch, listen, or download or subscribe to our episodes. You can do the same things at the GFQ website, gfqnetwork.com. And check out all of the other shows available on the GFQ network as well. There are some pretty good ones out there, and you're going to have a good time watching them. We'll see you next week, folks, on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pilfer this week. Another twort has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you like today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.